Okay, welcome everyone to this new series, which I call AI for the Working Mathematician. In case you don't know that, let me just pull it up. So there is a famous category theory book, which is called Category Theory for the Working Mathematician, like a really famous book. And the title is actually pretty good. So it is. I wouldn't recommend it as a beginner's book, but it doesn't claim to be a beginner's book. It claims to be categories for the working mathematician. So it's categories instead of category theory. I was the same way. Categories for the working mathematician, one of the most important books in the history of category theory. And I kind of have the same idea in mind. AI for the working mathematician. I'm pretty sure this will not be one of the most important video series in the history of AI. But the title is kind of inspired by the book in the sense that, yeah, I mean, it says it, right? It's for the working mathematician. Whatever a working mathematician is. I would like to explain what in 2025, if you're interested in math and adjacent areas, what actually AI can really do for you. Yeah? So everyday AI, what everyday AI can do for you. Because I feel like I talk to many colleagues and I kind of have the impression that people have the wrong impression. I kind of have the feeling that people have the wrong impression what AI actually in 2025 can already do. Because it can prove theorems for you, like genuinely new theorems. It's not super impressive in proving theorems. We are not on that level. But it can do that already, and it's very useful for many tasks. So at the moment, I feel like when I really talk to people, it's very clear cut between a part of people, part of researchers which use it like all the time, and another part which is really skeptical. It's kind of very clear cut. That's how it looks like, and I'm trying to convince you that it's more grayish, right? So it's not perfect. But it's not bad, and I really recommend using it. And I give you some practical ways of how I used it in my own research, and of how you can use it for fun in your own research, during a PhD thesis, whatever, just kind of in general. And I'm totally aware that this might age really, really badly, right? Nobody knows what the future holds, but I'm still doing it because why not, right? Keeping in mind that I will never be never be on this level, but we'll see where we end up in this business. So what I really like is this little picture here. So at the moment, this is my understanding of how human and AI work together, right? AI is not a separate bubble which can do everything itself, but it's much more useful, efficient, and actually designed, if you want, to interact with humans. Yeah. In particular, what I really like is this idea of that you guide AI. AI does something and you literally guide it. So for me, it always feels like, maybe I make this analogy, hopefully that works for some people. For me, it always feels like when I talk to students and I guide them towards the right idea, that's actually not so far off from how I interact with AI. Yeah. So you kind of already need to know where you want to go. So AI can't really do that at this point. But if you know where you want to go, you can actually make quite some progress using AI. And by AI, I say that again, I really mean everyday AI tools everyone can use in 2025, right? Everyday AI, that's what I have in mind. Not fancy models that solve a specific problem. That's also very efficient. I have a video series about it, but Anyway, I never recommend anything I've done. So that's kind of very different, right? So specific models to tackle specific math tasks, very efficient. There are a lot of papers in this direction. There are a lot of growth in this direction. But I'm more interested in this question: what actually everyday math can do for you, and by everyday math can do for you, what everyday AI can do for you. Yeah, and I'm assuming you're a working mathematician, whatever that means, right? And by everyday AI, I really mean the large language models, which have boomed quite recently. Yeah, and maybe some other small tools you can use. And yeah, this is really in 2025. And what they can do is it's really good. They can read papers and summarize papers for you, for example. Coding is a big thing. They're really good. Again, coding with this idea of that they can write nice snippets, nice little parts of a code block. Really good at that. But kind of the overall picture, you're still the one who guides the AI. Drafting your thesis, drafting a paper, excellent. Organizing how you want to write papers. Maybe the lemma should come somewhere else. Perfect. Small lemmas you can prove using AI. Works really well. Giving you ideas what to do in your research, how to continue. Excellent. Right? So, and I will also explain, so not just I will tell you a little bit of what you can do yourself, but I will also explain why you should expect this to work. Yeah. So certain things it can do really well, and I tell you why. And certain things, it's just not good at the moment. And I tell you why as well. Yeah, again here, I say that probably a million times. We're talking about 2025 here. So if you watch this video in 2030, you probably shouldn't. There will be hopefully some huge progress. We never know, but hopefully there will be some huge progress. And a slogan that I think works really well, and it's actually AI generated, is the following. You should really treat AI like a brilliant but unreliable collaborator, right? So you kind of need to still verify everything. You need to point it in the right direction. It might make mistakes. It might mess things up, but overall, it's actually pretty good. Yeah, the analogy with a student might work well as well, right? So brilliant student still needs some supervision, so you point them towards the right direction. That's essentially how I think about modern AI, right? So here's this nice picture. It's kind of pretty much a good summary of how I would like to think about AI. And yeah, in this video series, I really would like to address this. So here is something I did. I could have done this live, but I decided to. Sometimes, because it's unreliable, it's better to do it first before and then just put it on your slide. But eventually I will do some live things as well. So essentially, my favorite modern AI tool is this one. If you don't like it, there are others. They're essentially the same. This is not paid promotion or anything. It's just my bias. Huh? Most AI can roughly do the same for you. Some are better in X, some are better in Y, but roughly it will do all the same. Okay, that said, so essentially what I did is the following. I asked a very easy question. Can you prove that pi is irrational? And if you ever tried that, or you know kind of the proof of this fact, it's actually not so easy to prove. Pi is kind of a very nasty number. So proving things about pi is always a bit ugh. So it thought for 53 seconds. It's pretty fast. And it gives you a proof by contradiction. And this is one of the classical proofs, where you essentially write down a certain type of integral and then take it from there. Right? Why did I do exactly that? This proof is attributed to... there you go. So why did I tell you that? Because that's not what I have in mind. So AI can produce perfect proofs of well-known results. Even things that are not easy. Proving that pi is irrational is not easy. Yeah, and it can still produce essentially a perfect proof. But that's not what I wanted to talk about. I wanted to think about or tell you about how you can use AI to do something new. Right? Reproducing an old proof. I mean, that's fine. That's great. But it's not something new. Right? So what I really want to do is I want to tell you how you can use AI to produce something new. Yeah. So essentially, rigorous reasoning is still unsolved, and the main reason why it can reproduce the proof that pi is irrational absolutely perfectly is because there are 1,000,005 different versions of that proof all over the internet. It has read the data. It just reproduces it. Not very difficult. Still better than a human, essentially, because it has read a lot, right? So that's one of the main advantages. It has read a lot. And people nowadays don't read anymore. And I can still read. But something new is a little bit trickier. So I would say, again, proofs need supervision, but it actually can do really honest new proofs for you. It's not something great. You won't get the Millennium Prize or something by using ChatGPT. Not anytime soon. Maybe eventually, who knows, but I would say not before the end of 2025. We'll see. But AI still helps, right? That's a problem. It still can get you something. And I will be more specific and give you actually examples of what, as I said, what I have done in my research, right? How to use AI in whatever research means. It's probably also just fun to watch if you're not interested in research, or you're writing your thesis, or you're just generally interested. Again, it's for the working mathematician, but whatever that means, it doesn't really matter, right? I also want to tell you why it works, as I said. And we'll see, right? Say it again. I don't have things like this in mind. Reproducing well-known results, it can do that very well. One of the big problems, I kind of feel like it's not really a problem. I will tell you my opinion about it, but let me address it first. One of the big problems university education is facing at the moment is that the assignments the students are usually doing in any of the STEM fields, right? STEM fields is a lot about assignments, so exercises you do and then hand in. Essentially, all of these are well-known things, and they're somewhere on the internet. So some large language model should be really good in just solving the assignments for you, and yeah, it can, right? So in my experience, it's usually actually better at the moment than the average student. So what it is, I think it's better than the average student, but worse than the good students. Somewhere in the upper echelon of things, but not quite at the top. But anyway, huge problem. But to me, it feels like it's the same as when the calculator was introduced into mathematics, and people were like, "Oh, we all forget how to do integrals." So it's kind of the same. I feel like it's fine, but you should keep in mind that there's a huge discussion because AI can reproduce well-known things very well. And I know I sound like a broken record by now, but it's kind of important. That's not what I'm interested in. I want to have AI produce genuinely new things. Okay. And here's another nice picture that I would like to have in mind. So everyday AI, again, I just identify that as whatever kind of large language model you have in mind. And their main upshot is that they have read a lot. Yeah? They have read a lot. They're very smart. They're not smart. They have just read a lot. If you have read a lot, then you're not necessarily smart, right? And so they can reproduce known things really well, really efficiently. So they're good at supporting workflows. Yeah, they're good at reading a paper and comparing it to something else. They're good at things like writing a referee report for papers. Yeah, have I done that? Yes, but again, in this setting of you just don't take it and copy it directly, right? You polish it, but it's pretty good at this. Same with coding and writing and whatever, something like that. Huh? It's really good for that because it has read a lot of things. And a huge problem in modern research is that there's too much research and not enough people actually read papers anymore. Not enough people read papers. There's too much research. So eventually we'll fall behind. There will be discoveries that run in parallel. And this is where AI is like really good because it has read all the bullshit. Right? It doesn't really understand the bullshit, but it has read it. It has read it all. So if you have a question and it looks like this could be something someone had thought about, maybe in a different field I'm not aware of, it's somehow a good idea to ask AI about it. Maybe there's a name for it and you don't actually know the name. It's pretty good. What it's not particularly good at least at the moment, is reasoning, essentially. Right? So you somehow need to guide it to get the correct results, as I said. Yeah? But the main advantage, and it's kind of easy to approximate what it can do, is because it has read a lot. It can do all these tasks where you compare things. That's really good. Or where it just pulls up something that is well known. It's really good at that. And I also want to highlight, so this is essentially how a transformer works. We don't really need to know that, but essentially it's just the attention, the idea of attention. So essentially we're talking about everyday AI. I essentially talk about attention, the transformer type idea. So here roughly that's what it usually is. It's called the hype cycle. Very nice. So some technology trigger happens, and whoop, there's a boom, and eventually the boom dies. It's actually not as good as we thought, but eventually it will kind of stabilize on a certain plateau of productivity. I can't tell you where we are in the AI right now, but in a few years it will just stabilize somewhere, and hopefully that we will have a nice interaction between humans and AI. And I hope to get all of us on this plateau of productivity as fast as possible. So I would still recommend just doing it. But keep in mind that eventually, so this is how the hype cycle is essentially how this usually works. This is, of course, an empirical observation, so a model, but it's not unexpected to happen for AI as well, right? There will be a peak somewhere, and then maybe not, and then it will stabilize on a certain level. That's usually what it does. Okay, to wrap up this video, let me tell you what it can do for you in general, like really well, and kind of how you should place the results. So this is a fun thing. So this paper, which is here on the slide, they've done something funny. They have discovered new formulas for whatever, pi, the golden ratio, square root of 2, ln 2, the numbers people like, using AI. So it can actually do that. Here's a fancy formula for pi, or for 6 over pi squared, I guess, or 12 over pi squared. Golden ratio, what the heck, or some formulas like that. So that's what you should think. So they have discovered these formulas using AI. Yeah? It's a really nice paper. And that's what it can do very well. Well, already at this stage, this was end of 2024, so 12, so December 2024, it can already do that. And essentially, it went through millions of expressions and rediscovered the new formulas for those guys. So it has read the literature very well, if you want, and then can actually go a step further by combining things in a bit of a smarter way, and maybe you get some new formulas, whatever, like the golden ratio formula, I think, which was not known before. Who would ever write that down, right? So who would ever write that down? It's kind of a very nice result, and that's essentially how I think about AI at the moment, right? It can do something new because it pieces together things from the literature it has read in a novel way, and the output is actually something good. That is not impossible. That can happen. So you can use it to prove theorems. You still have the supervision. So it will kind of put out this formula, and you still need to kind of have a mathematician or someone to double check that this is actually true. But this is roughly how it works, right? So it's kind of a very nice paper. So if you want to check it out, here's a link. That wasn't a large language model, but I used it for comparison because it kind of compares very nicely. Well, so all of these things, and then, yeah, if you look at the things humans have discovered, like the formulas here, the efficient infinite series, whatever, I thought this formula was particularly pretty crazy. So I've never seen that one before. But this is kind of a fun formula. Who would ever come up with that bullshit? But anyway, so if you look up kind of expression formulas for pi and whatever, the ones humans found, it's way more impressive than that thing here, which is really just a continued fraction. It's much more impressive. So kind of it's still lacking behind. So it can do new things, but at the moment, what it can, so humans are usually more efficient than AI. I say that again, my analogy is, if you feed in whatever a linear algebra exam into AI and compare its performance to the average student, the AI will likely be better at this point. But if you compare the performance to the top performers, the best students, the AI will likely be worse. Yeah? So that's what it is, roughly is. So it can do things for you, but human level is usually better. This is another example here. So the formulas you get, they're pretty nice, but somehow a bit restricted in their scope, right? Compared to other formulas here, the kind of Ramanujan type formulas that you see here. And you really should expect the same from everyday AI. Kind of you'll go through that, right? You shouldn't expect breakthroughs. Not in 2025. You shouldn't expect breakthroughs, but it's still really, really useful. And hopefully this series will convince you and give you some new ideas what you can actually do with AI. Anyway, I hope you enjoyed this video, and I also hope to see you next time.